Bismillahirrahmanirrahim, dear students. Yesterday or before this day we did a topic about the Biot law, and today's topic is Ampere law. As you see from electrostatic, Coulomb law deals with the static charges, and with the help of Coulomb law of any kind of charge distribution using principle of superposition we can find electric field as well. But if the symmetric charge distribution is over there, then we can apply Gauss's law. Gauss's law is one of the basic law, which is the equation of one of the equation of Maxwell equation, which are four in number. Similar is the case with the Ampere law. In case of Biot law, if the symmetry is not there, then we can find the value of B using Biot law. But when there is a high symmetry, then in that case we use Ampere law to find the value of B magnetic conduction. So what Ampere law states? Ampere law states that the line integral, this is a line integral of a magnetic field along a closed path or loop. Line integral of a magnetic field along a closed path or loop is equal to mu naught times the total current enclosed. What Gauss's law Ampere law states? Ampere law states that the line integral of a magnetic field around a closed path or a loop is equal to mu naught times the total current enclosed. For this purpose, consider a conductor which is placed perpendicular to the magnetic field. Let amount of current I is flowing through that conductor. As we know that around the wire or around the conductor there will be magnetic field. Around a wire or around a conductor there will be a magnetic field. Let us say I is the amount of current flowing through this conductor. What will happen? This conductor will provide or produce magnetic field around it. And the magnitude of the field, that is magnetic field around the conductor, is directly proportional to the amount of current flowing, inversely proportional to the distance r from the conductor. How? If I increases, then B increases. If I decreases, then B decreases. Means if a large amount of current is flowing in the conductor or small amount of current is flowing in the conductor, then in both cases the value of the magnetic induction varies. That either it increases or either it decreases. Similarly, the magnetic induction or the magnetic field which is produced by the wire carrying current, that is inversely proportional to R. Means, for example, if you follow this closed loop, or if you follow this closed loop, or if you follow this closed loop, on this loop, on this loop, on this loop, the magnetic field or the magnetic induction value will be different. It is inversely proportional, means if R is greater then B will be less, if R is less then B will be greater. So it means that B, that is the magnetic induction which is produced by the current carrying conductor, depend upon amount of current flowing, it also depend upon the distance R from the conductor. Now combining the both equation, we have B is directly proportional to I over R. B is directly proportional to I over R, or B is equal to mu naught divided by 4 pi I divided by R into n unit vector. This is the magnetic induction value which is produced by the wire carrying current. Wire carrying current. Now, how we can find the value of the line integral of a magnetic field around a closed loop or along a closed path? We divide this path into smaller segments, or this path, or this path. We divide it into smaller segments. For example, there is a wire carrying current, and around the wire there is a magnetic field. Let us say this is a small element, length element dl, and this wire carrying current I, and this small current element is at a distance r from the wire. Now, in order to find the line integral of a magnetic field along a closed path or a closed loop, we divide into smaller segments dl. For example, this dl, etc. And then we find the value of b dot dl for this length element, value of b dot dl from this length element, value of b dot dl for this length element, for this length element, and then we take its sum. And then we take its sum. Means, for example, dividing the circle into small length element dl, and for each length element b dot dl is calculated. Yani you must calculate b dot dl from this element for this portion, for this element, for this element, and then taking the sum of quantities b dot dl for all elements. यानी क्या लेना होगा, इसी का सबका क्या लेना होगा, sum लेना होगा. Then from there you see integral on closed path b dot dl is equal to mu naught I n unit factor dot dl, taking mu naught I divided by 4 pi r out, integral on closed path n unit factor dot dl cos angle 0 इसमें है, तो आपके पास आ जाएगा इंटीग्रल ऑन क्लोज पाथ b डॉट dl इज इक्वल टू म्यू नॉट I डिवाइडेड बाई म्यू नॉट I डिवाइडेड बाई म्यू नॉट I डिवाइडेड बाई 4 pi r, 2 pi r, it will goes towards the 0 to 2 pi. r d theta is the length, arc length value. S is equal to r theta. Here the length element is dl is equal to r d theta. तो ये r d theta यहाँ पुट कर दें और इसकी इंटीग्रल ले लें. 0 to 2 pi r बाहर निकालिए, कैंसिल हो जाएगा. 0 to 2 pi इंटू डी थीटा या म्यू नॉट I डिवाइड बाई 2 pi, और थीटा जो है आपके पास 2 pi माइनस 0 2 pi कैंसिल हो जाएगा. आपके पास आ जाएगा इंटीग्रल ऑन क्लोज पाथ b डॉट dl इज इक्वल टू म्यू नॉट I. अच्छा, इससे पहले के यानी गॉसेस लॉ किया था, कूलम्ब लॉ किया था, बायट-सावर्ट लॉ किया था और एम्पेयर लॉ करा रहे हैं. तो दोनों में तीनों में फ़र्क ये है, चौथों में, कि गॉसेस लॉ जो है वो हाईली सिमेट्रिक चार्ज डिस्ट्रीब्यूशन अगर आपके पास हो तो हम गॉस लॉ अप्लाई करते हैं. अगर एनी काइंड ऑफ चार्ज डिस्ट्रीब्यूशन है, पॉइंट चार्ज है या आपके पास 2-3 चार्ज डिस्ट्रीब्यूटेड हैं, तो विद द हेल्प ऑफ प्रिंसिपल ऑफ सुपरपोजिशन हम कूलम्ब लॉ अप्लाई करते हैं इन ऑर्डर टू फाइंड द वैल्यू ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी. अब मैग्नेटिज्म केसेस में हम क्या लेते हैं, इसी केस में विलियम व्यू को मालूम करने के लिए अगर हमारे पास ये हाईली सिमेट्रिक वो नहीं है, हाई सिमेट्री इन्वॉल्व नहीं है, तो हम बायट-सावर्ट लॉ की मदद से विलियम व्यू को मालूम करते हैं. अगर हाई सिमेट्री इन्वॉल्व है तो फिर हम एम्पेयर लॉ की मदद से इसको मालूम करते हैं. तो अब ये आपके पास एम्पेयर लॉ की इक्वेशन है. अब एम्पेयर लॉ जो है डिफरेंशियल फॉर्म में आप इसको किस तरह लिखते हैं, जो कि आपके पास एक मैक्सवेल इक्वेशन है, डेल क्रॉस बी इज इक्वल टू म्यू नॉट जे. दिस इज द डिफरेंशियल फॉर्म ऑफ एम्पेयर लॉ. यानी एज यू नो एम्पेयर लॉ इज इंटीग्रल ऑन क्लोज पाथ बी डॉट dl इज इक्वल टू म्यू नॉट I. दिस इज एम्पेयर लॉ. अब आपने क्या करना है, I की कीमत जो है इसी केस में B dot dl is equal to I is equal to integral j dot ds, where j is a current density and ds, j is a current density, and I is equal to integral s j dot ds. Putting the value of I in this equation, that will give you integral on closed path b dot dl is equal to mu naught I, in this case is integral s j dot ds. Now apply Stokes theorem on the left side of this equation. Apply Stokes theorem. Once you apply Stokes theorem, it becomes curl of b dot ds integral of s is equal to mu naught integral s j dot ds. और you can also write, इसको इधर ले आए, इंटीग्रल ऑफ एस कर्ल ऑफ बी डॉट डी एस माइनस म्यू नॉट इंटीग्रल ऑफ एस जे डॉट डी एस, या इसको मतलब एक इंटीग्रल एस डी एस जो है ये ड्रॉप आउट करें तो आपके पास आएगा कर्ल ऑफ बी माइनस म्यू नॉट जे इज इक्वल टू ज़ीरो, और कर्ल ऑफ बी इज इक्वल टू म्यू नॉट जे, तो कर्ल ऑफ बी एस आपके पास क्या है, डेल क्रॉस बी है विच इज़ इक्वल टू म्यू नॉट जे. तो आपके पास ये डिफरेंशियल फॉर्म है एम्पेयर लॉ की.